So it's finally time to start on the main topic for this module, and that is OAuth. We'll start naturally with what is OAuth? Well, it's a standard defined by an RFC, and it defines a kind of framework to enable one web service to share its data with another web service or website. And that will be in a secure way and with the express permission of the person who actually owns the data. In this chapter, I'm going to give a very high-level overview of the process involved in OAuth. I'm going to miss out some details, and in a few cases I will be deliberately oversimplifying. But that's fine, because in the next chapters we'll be taking this theory and we'll be applying it for real to our CRM and MailMonkey projects. And when we do that, we will fill in all of the fine details. The CRM and MailMonkey projects are a great way of explaining the concepts. The scenario is that the team behind the CRM system have decided that it would be great if third-party applications could integrate with the CRM system. So the idea behind MailMonkey is that users can log in and they can generate newsletters, which they can send to a mailing list. Well, their problem is, of course, how do the users get a mailing list in the first place? Of course, there will be a lot of ways. You might be able to type in your own list of email addresses, but MailMonkey have decided to support a feature where, if the user also has an account on the CRM system, then the users can import their contacts from the CRM system automatically into the MailMonkey system. So that's the scenario that we'll be following on this course. We'll use it as a case study to explain the OAuth concepts. Before we go any further, there is one complexity that I want to get out of the way, and that is different versions of OAuth. OAuth 1 has been around since 2007, and it became an RFC in 2010. It's been in common use since then. OAuth 2 was published in October 2012. And the difficulty is that although they share the same sort of overall structure, and certainly the end goal is the same, there are huge differences between 1 and 2. I think of them as being like two completely different frameworks, in fact. To simplify the differences, in OAuth 1, the messages that we send between the two web services were encrypted using a signing mechanism. And it was kind of our responsibility as developers to do that encryption. Now that's good because it made it very secure, but it did make OAuth difficult to implement. OAuth 2 is easier to work with because it doesn't have the signing and encryption. So we're going to be sending the data from one system to another in clear text. But don't worry, we still encrypt the traffic, we have to, but we do that using SSL or TLS. So if you like, the encryption part of things has been taken out of the OAuth framework, and in a way, we don't have to worry about it as developers. I say in a way, of course we have to worry about it. We have to be absolutely certain to use SSL and to do it properly. But we don't have to kind of programmatically do any encryption work in the process. This has been deeply controversial. I will let you research the arguments for and against OAuth 2 for yourself, but I think I just want you to remember that OAuth 2 is a bit easier to implement, but also it's easier to make a mistake. If you were to misconfigure the SSL TLS, then your application is compromised. So keep that in mind. As usual, on this course, we'll be adding TLS, SSL at the end of the development, but you've got to remember all the way through this work that it is absolutely needed. At the time we recorded this course in 2015, OAuth 1 and 2 are both in common use, but because OAuth 1 is now dated, you can think of it as being deprecated, we're going to focus entirely on version 2. If there is sufficient demand, then I might add an extra chapter to this course covering OAuth 1, but I kind of feel that as long as you understand everything that's coming up on this course on OAuth 2, then if you ever need to, it should be relatively easy to learn OAuth 1 for yourself. So OAuth 2 is our focus here. So why do we want to use OAuth in the first place? Well, we'll start by looking at how we might have implemented this CRM and MailMonkey integration without OAuth. And it is a very bad way of doing it. We could have simply, and here is a mock-up of the import contacts from the CRM system page. And all we're doing here is we're saying to the user, please give us your CRM username and password, and we will use that to make a request to the CRM system to get your contacts. I hope it's fairly obvious that this is a terrible way to implement it. Now, plenty of websites do this. It's pretty common, although it's thankfully less common than it used to be for sites to say exactly this. Hey, give us your email address and password and we'll import all of your email contacts or whatever. It is still out there. I'm aware at the time of this recording, some online personal finance managers, I won't name them, but they are still doing this. They ask you for your banking credentials so that they can do things like import your bank statements into the personal finance manager system, which I'm sure is very convenient, but I hope you would never consider using such a service. It's horrible because you are entrusting some unknown entity, MailMonkey in our example, or the personal finance system, with some of your most precious data. Of course, you should never share a password, least of all a banking password, with anybody. And yet sites like this are asking you to freely give it away. This is commonly referred to as the username password antipattern, and this is exactly the problem OAuth is going to solve. Through this chapter, I'm going to be explaining the interactions between the user, the MailMonkey system, and the CRM system by using captions that look something like this. This is actually a simplified version of a sequence diagram that you might be familiar with from UML. I thought as a warm-up, I would go through the username password antipattern using this sequence diagram style. So let me remind you, this is the way that we are not going to do things. So here is our user sat at their browser at home, and they will have presumably logged into the MailMonkey system to start the whole process off. I'm going to be consistent with our real life code, so I'm going to have this user having a login username of MM and a password of MM. So they've authenticated themselves with the MailMonkey system, and the MailMonkey system is going to respond with the page that you just saw previously. This is the import contacts from CRM page. Well, this page is asking for the user's CRM username and CRM password. So this unfortunate user, if they decide to do so, might enter their credentials for the CRM system. Again, as you saw in previous chapters, their username for CRM is RAC, I've decided just to carry on with that just for consistency there. It's actually my common login name, Richard Alexander Chesterwood, and the password of secret. So MailMonkey has gathered this username and password, and that is the unacceptable part of this process. But it does work, and at least it's simple, because then MailMonkey could simply take that username and password, a REST request, to the CRM system. We saw in the previous chapter exactly how to do that. The controller here in MailMonkey could simply use the REST template. If we're assuming they're using Spring, they would use the REST template to make a request to the CRM system, which is going to respond with the customer data, which MailMonkey can then turn into a web page, which it would send back to the user, and it might look something like this. Well, it did work, but I hope I've convinced you that this is a terrible way of doing things. I did want to run through the caption there because we're going to be using this style of explaining things quite a lot through this chapter. Let's forget then about the password anti-pattern, and we're going to bring in OAuth 2 to rescue us. With OAuth, we're going to allow the resource provider, which in this case is the CRM system, to give access to some or maybe all of the resources that are owned by the user to a third-party system. The overriding goal is that the client application, which in our case is MailMonkey, will never get sight of the user's CRM username and CRM password. Well, I realise that I've used some terms here on this caption, such as resource provider, and it might not be clear exactly what that means. But actually, these terms are defined in the OAuth specification, so it's worth doing some formal definitions. Let's start. In fact, what we're doing here is we're describing the different actors that are going to be taking part in the OAuth process. And the first of those actors is the resource provider. The resource provider is the application, and that means the web service, really, will usually be a web service that is storing the shared resource. So that's easy. In our example, it's the CRM system. Now, notice that I'm going to be very careful here not to say this is the server, because that would be ambiguous. We've got two servers involved in this process. There's the MailMonkey server as well. So we're going to be very clear that this is the resource provider. Then we have the client application. Now, this is the term that I have sometimes got confused about in the past. Sometimes you might think of the client as being the end user. You might think of the client as being the browser that they're using, but it isn't. In OAuth, the client application is strictly the application that is requesting the shared data. So in our example, very clearly, the client application is MailMonkey. Then we have the resource owner. I'm sorry about the lame clip art here. I hope it will do the job. Now, this is the entity that actually owns the data on the resource provider service. I say entity, for most practical purposes, I guess this is going to be a person. They're going to have a login to the client application and a login for the resource provider. And of course, they will in general be different usernames and different passwords. The other huge concept in OAuth is the access token. And it's the access token that OAuth uses to allow our client application to access the resources. On this caption, I'm doing a very high-level description of the OAuth process. There's a lot missing from this caption, but it does explain what the access tokens are going to do. The resource owner is going to start the process somehow. Now, not quite clear what that means just yet. I imagine this might be something like the resource owner has gone to the MailMonkey import contacts page. What will happen then is we're going to have some kind of exchange going on between the client application and the resource provider. Now, there's a lot of complexity there. We'll be talking about that in just a few moments. But the end of that complexity, if everything is checked out and the resource owner has successfully logged in and everything has gone okay, then the end result will be the CRM system will send back to the client application this so-called access token. The access token in general is going to be a long string. It could be a string of numbers, it could be characters. Actually, the OAuth specification doesn't define the contents of the access token. It just needs to be, if you like, cryptographically secure, by which I mean a hacker couldn't guess a valid access token. It's going to be one of those strings that has so many combinations that it's astronomically impossible to guess a valid access token. And it's this access token that MailMonkey is going to store. So MailMonkey does not have the user's CRM username and password, but it can use this access token to access the resources on the CRM system. So MailMonkey might make a request to the CRM system, which will probably be a REST call. As long as they supply the valid token for that user, then the CRM system will respond with the data. Of course, if the token is not valid, then the CRM system would respond with an exception. But let's assume everything has gone well. Once MailMonkey has this customer data, then it can respond back to the user with a page of its own containing that data that it's imported from the CRM system. This is an incredibly oversimplified view of how OAuth works. In particular, this part needs a lot of elaboration, but I hope you get the idea behind what the access token is all about. So I really need to go into a lot more detail about how this part of the process works. And this part of the process in the specification is called a grant type. Not a very meaningful phrase, I think. So I might sometimes call it a flow. The grant type is the series of operations, the series of messages, if you like, that are going to be sent from the resource owner to the client application, and from the client application to the resource provider. It's those series of operations that have to be carried out in a certain order, which is called the grant type. Well, OAuth defines several different flows that you can use, and they call these the different grant types. The different versions are there to support different types of device and different requirements that your architecture might have. But the full OAuth, and what is definitely the most secure flow, and it's the flow which I think of as being OAuth, is called the authorization code grant type. I'll be explaining over the next few minutes why it's called authorization code grant type. Now, I know it's quite jargony, but if you just want to think of authorization code grant type as being the full, most secure form of OAuth, then you won't go far wrong. We will be looking at the other grant types in a later chapter, but really, the other grant types are just simplifications of the authorization code grant type. So once you've learned this, once you've done this chapter, then the hard work is done. And I think you should always be using the authorization code grant type unless you have a very good reason not to do so. I'll be telling you what some of those reasons are in that later chapter. But I have seen some people implementing one of the other grant types just because it's simpler. And that's a bad mistake because you want the full security, if possible. So the default for you should be the authorization code grant type. The reason that this grant type is the most secure is that we authenticate not just the resource owner, but we also authenticate the client application as well. In the authorization code grant type, the resource provider at the end of the process will know, is the user a genuine resource owner? We're going to do this by getting the user to log in to authenticate themselves onto the resource provider site. So that's nothing more complicated than the user will also log in to the CRM system, and they will do that directly. They won't do that by passing their username and password through the MailMonkey system. The second thing we will have achieved by this grant type is the resource provider will know what resources the resource owner wants to expose to the client application. It might be that the resource owner is happy to allow MailMonkey to read their customer data, but not to read any other kind of data. And it might be that they're not happy for MailMonkey to write new data to the CRM system. And in OAuth, we can have quite fine-grained control over those permissions. And thirdly, the resource provider will also check out that the client application is a genuine one. And that's to stop fake sites tricking a user into giving authorization. You could imagine a criminal could set up a site called MailMonkey, which is of course a slight misspelling of MailMonkey. Well, that site's not known to the resource provider, so this process would fail. And I think really it's that step that really gives the authorization code grant type its full power. Well, that's quite a lot to take in, and there is a lot of work involved in making all of this happen. By the way, it's sometimes called three-legged authorization and authentication, or three-legged auth, because there are three distinct parts to the process. And what we're going to do now is we're going to go through each of the three legs. Now, there is a lot of information coming up here, and you don't need to remember it all, because we're going to be reviewing all of this when we actually come to build our solution in the code. So I'd kind of like you to just get the feel for what's going on here. Although I am about to go into a lot of detail, I'm still going to cut a few things out that we don't need to think about just yet. So here we are in what I'm going to call leg one of the process. We have here the MailMonkey system, and here on the far right, the CRM system, and here's the user or the resource owner at their browser. I have 3 copies of the clip art there because, as in all sequence diagrams, time is going to be going down in this direction, and leg 1 needs quite a few interactions with the browser. So, starting at the beginning, we can assume that the user has already logged into the MailMonkey site, and they will have done various operations on that site, perhaps, but then at some point they visit the Import Contacts page. Well, that means that we need to start off the OAuth process. And the way that we start the OAuth process is by sending a GET request to a particular URL on the resource provider. Now, the URL that I'm showing you here is /authorize. That's not specified. You could redefine that URI to be anything you like. But what I'm going with here are the defaults that we're going to get in the Spring framework. So think of the authorize URI as being the URI that we're going to use to kick off the whole process. Now we need to send several parameters to this URI, but I'm showing you here the two most important. There's the client ID and there is the redirect URI. Now the client ID is, as it suggests, is a unique identifier for the client application. Can I be absolutely clear about that right now? That's the ID of the application, not the ID for the user. Do not think of the user at the browser as being the client. The client is MailMonkey. So we will make sure that every client that is able to interact with this resource provider is given their own client ID. You'll see why the client ID is needed in just a moment. And similarly, we'll see why the redirect URI is important as well. By sending this request to the CRM system has now taken over, because in response to this request, the CRM system is going to send back to the browser its login form. That is, by the way, assuming that the user hasn't already logged into the CRM system. Now, this is really important. At this point, the user at their browser is now no longer on the MailMonkey site. They are now on the CRM system site. So, if they decide to do so, when they provide their username and password, they're sending that directly to CRM, and the MailMonkey system will have no visibility of that username and password. So I hope that's okay. That fulfills the first of our requirements. The CRM system knows that, yeah, the user is a valid user. They are who they say they are. But then the second requirement of the OAuth process was that we want to know, does the user give permission to share some of their data with a third-party site? So the next step in this leg is the CRM system will send a page back to the user saying the application MailMonkey wants to read some of your customers. Do you agree or do you disagree? This, by the way, is one of the reasons why we needed to send this client ID. It's so that we can echo that client ID back to the user so the user knows what's going on. Let's assume that the user is happy to proceed, so they send back the response, yes. Well, this is really the end of leg one now. We've satisfied the first two of our requirements. We have a bit of a problem, though, that we have now gone to a different site. How do we get back to the MailMonkey site, which after all is the site that the user is wanting to continue to do their work on? Well, easy, really. And you can probably guess from the parameter that we sent here in the redirect URI, the CRM system will send back a HTTP 302, which you probably know is a redirect, and it will use exactly the URI that we sent it at the start of the leg. So this URI is going to be the URI probably of the page that the user is ultimately going to be interacting with. You might think of it as the landing page for this process. I've decided to call it the MailMonkey import page. And because we've sent this redirect back to the browser, that will tell the browser to make a request to go to this page. So I hope that leg makes sense. The high-level description of leg one is these are the operations required to make sure the user is who they say they are and for the user to give their permissions for the data to be shared. Notice there is a code here on the redirect. What's that all about? Well, you might at first think, oh, well, that's obviously the access token that we were talking about not long ago. The access token, remember, is the key that gives the client application full access to the resources. Well, it isn't. This is the authorization code, and it's really important to distinguish that from the access token. The authorization code is where the grant type gets its name from. All this authorization code is it's a way of the server recording that leg 1 has been completed for this user. And it's going to unlock leg 2 of the process. Without this code, we wouldn't be able to continue with leg 2, and the authorization code is just there to stop hackers trying to cut off the first leg of the process. So the authorization code is definitely not an access token. Again, the OAuth specification doesn't say what format this code should be in, but you will typically see this code being a fairly short collection of characters because it doesn't particularly need to be cryptographically secure. So where are we at after completing leg 1 of the authorization code grant type? Well, we know that the user is a genuine resource owner because they've logged into the resource provider, and because the user has clicked on the approve button or the yes button, or whatever it was, we know that the user, the resource owner, is happy to share a particular set of resources with the client application. But what we haven't done yet is we haven't checked, is the client application valid? Is the client application a genuine one? So that's going to be the focus of leg 2. We want to know, is the client genuine? Well, why do we care about that? Well, because without that step, it would be easy for a rogue application to spoof the client and potentially con innocent users into giving access to their data. Now remember, what we're talking about in this leg is the client application and not the user. So we need to make sure that MailMonkey is genuine. So what we will need is a username and password for MailMonkey itself. But to avoid confusion, OAuth doesn't call it a username and password. Instead, it's called a client ID and a client secret. And that's just so that we don't think the username and password belongs to the user. So for MailMonkey, and we will persist this through the code, we'll have a client ID of MailMonkey and a client secret of the string some secret key. Of course, in real life, that would be equivalent to a proper secure password. Now, I've just invented that ID and secret out of thin air, but you might be wondering, in real life, where is that going to come from? Well, just really as with registering users, that is going to be something that has to be agreed between the client application and resource provider. It might be that the CRM system has a special page where if you're a developer of a client application, you can sign up on that page, and then the CRM system would give you an ID and a secret key, and then you would take that ID and secret key and put it into your code. Or it might be that the CRM system, for example, has decided we're going to support 4 of the big applications out there in the real world. We're going to support MailMonkey, Microsoft Outlook, Facebook, and LinkedIn. And these are the only 4 we're going to support. So maybe they might even hard code that into some kind of database on their system. Then they would contact MailMonkey and say, okay, we've given you a client ID and a secret. You need to include that into your source code. For this course, we're going to go with a hard-coded client ID and client secret, but I hope it's obvious that in real life you would have to provide some way of allowing your third-party client applications to register. So all of that has to be implemented in leg 2. Leg 2 is going to start by the user's browser sending a GET request to the redirect URI that we saw on the previous caption. Let me be clear about that. It will be the browser invoking that GET request. And it's doing that because remember the end of leg 1? The end of leg 1 was a redirect. So that causes the browser to automatically make a GET request to that URI, including the authorization code. So the user won't know this has happened, they won't feel that, all of that will be automatic. And actually, the whole of leg 2 is going to be transparent to the user, because now that MailMonkey has received this GET request, it crucially has the authorization code. So we know that leg 1 is completed and it needs to invoke leg 2. In leg 2, the client application will send a request to another URI. I'm working here with the Spring default URI, which is /token. You'll see why it's that URI in a minute's time. Now remember, I've said that effectively this leg is all about MailMonkey authenticating itself to the CRM system. So to do that, it's going to have to send its client ID and its client secret. But also, so that the CRM system knows that leg 1 has been successfully completed for this client, it will also have to send the authorization code that we obtained in leg 1. That will normally be a REST call, because this is the MailMonkey code making the request. Again, this will be transparent to the user. The CRM system will then need to authenticate MailMonkey. So it will do that by checking that the client ID and the client secret match. And if they do, then the CRM system will respond back to MailMonkey with, now remember that was a REST call, so it will typically be something like a JSON document, and this is going to contain the access token. And although you're probably feeling tired and punch drunk at this stage, I certainly am, this is a great point because it means now MailMonkey has what it needs in order to access the resource in leg 3. But before we go on to leg 3, let me just summarize what we've done here. We've achieved the 3 goals that we set out to do. We know from leg 1 that the user is a genuine resource owner and that they're happy to share that data with the client. And in the second leg, we now know that the client application is definitely valid. They are who they say they are, and they aren't some kind of rogue application trying to steal data. Now, the user was not involved in leg 2 at all. So the user is still sat there waiting for some kind of web page to be returned back to them. And that's what we're going to finally achieve in leg 3. Leg 3 will be initiated by the client application sending a second REST call. This is the REST call that is requesting the actual data. So for us, it's going to be something like /REST/customers. But importantly, they will also be sending the token. Now I'll tell you when we get there how that token is actually sent. It's not that simple, that, but the point is the token is sent along with the request. And now the provider can check, is that token valid? And I haven't really made this clear, but I hope it's fairly obvious that the resource provider will have stored somewhere, will have stored a list of all of the valid tokens. This one is a valid token, so the CRM system will respond with the usual JSON data or XML data or whatever that we expect as a result of a REST call. And what a relief, we're finally there. MailMonkey now has the data it needs, so it can build a web page and return it back to the user. Now, as the user does further operations on the website, we don't need to repeat leg 1 and leg 2 because the authentications will persist. So leg 3 will effectively keep being repeated with the same access token. And that's it for the full process. The client application will be able to use that access token for this user as long as it's still valid. I want to note, though, that access tokens are usually only made to be valid for a short period of time. They have an expiry, and that might be an hour, it might be a day. It's up to the coder of the resource provider. Now that is because an access token, I hope you realize, is a very precious resource. If it were to get compromised or stolen, then it's almost as bad as the resource owner's password being compromised. So their limited lifetime gives a bit more security. Even so, the access token must be kept completely secure. It must never be sent back to the user's browser as a parameter in the URL or something like that. It must be stored here in the client application, and it must go no further than that. And it has to be stored securely in a way that no external users can access. And I'm going to say one more time, in OAuth 2, the whole foundation of this system is that all of these transmissions from the browser to the client application, and from the client application to and from the resource provider, these must be encrypted using SSL TLS. If not, well, a man-in-the-middle attack is trivial. Somebody could easily steal the access tokens, or indeed the usernames, passwords, and client secrets. Well, they could all be stolen. Now that is a lot to take in. I'm going to go off for a lie down now before we do the next chapter. That's where we're going to be actually implementing OAuth for real. So if there's anything you haven't understood in this description, don't worry, we will be reviewing and going into more detail as we're writing the code.